Assalamu alaikum warahmatullahi wabarakatuhu. Today I am going to start with the last lesson in chemistry, that is lesson number 9, carbon and its compounds. You have done this chapter earlier in brief, and you know that carbon is an element and included in the non-metals. It has a symbol C and an atomic number of 6. You know its electronic configuration, that is 2 and 4. That is 2 electron in the first shell, K shell, and 4 electron in L shell, that is the valence shell. So its electronic configuration is 2 and 4. Possesses 6 protons and 6 neutrons. Just because its electronic configuration is 2 and 4, atomic number 6, so the number of protons are 6 and the number of neutrons are electrons also 6, and it has the mass number 12, and so it possesses the number of neutrons also equal to the number of protons, that is 12 minus 6 is 6. So all the three, that is protons, neutrons and electrons, are 6 in number, and it shows a valency of 4 because it has 4 electrons in the outermost shell. Is it clear? Now carbon is one of the most widely distributed elements on the earth. So you can see the distribution in the form of fossil fuel, peat is a form of coal, then land biota, that is the soil, includes all the soil and organic matter present in it, then all the dissolved organic matter in water, then it is a constituent of soil, and of course gas hydrates. So we all know that all living things, whether be it plant or animals, are made of or are they contain carbon, and whatever food that we are consuming, we are having, that is in the form of grains, wheat, rice, bajra, maize, whatever we are having, they are also the major constituent is carbon. Pulses, sugar, tea, coffee, paper, wood, kerosene, cotton, etc. are all made of carbon. And carbon is derived from a Latin word, that is carbo, which means coal. Is that clear? So carbon is found in the earth's crust, and it is present in both free and combined form, that is in the free state and in the combined state. In the free state, it exists as the various allotropes of carbon, that is it is present in the form of coal, in the form of charcoal, coke, diamond. This is the free state of carbon. Well, in the combined state, that is in the form of various compounds, it is present in the form of carbon dioxide, that is the gas which is being used by the plants for the process of photosynthesis, and animals and human beings are exhaling out carbon dioxide. Then the petroleum and natural gas is also the combined form of carbon. Then food, nutrients like carbohydrates, fats, protein and vitamins. The major constituent is of course carbon. Then carbonates, that is limestone, calcium carbonate, marble, again calcium carbonate. Is that clear? Calcium carbonate, marble and limestone, chalk and washing soda, of course Na2CO3 containing it's also a carbonate. You can see CO3 over here. So they all are the combined state of carbon. Then the compounds of carbon, hydrogen and the derivatives, that is whichever compounds are derived from these two compounds in combination, they are called as organic compounds. So compounds which contain carbon and hydrogen and the derivatives, they are known as organic compounds, and the branch of chemistry that deals with the study of these compounds is known as organic chemistry. So what all compounds we are using, or whatever things we are using in our day to day life, they all contain carbon. That is, whatever food nutrients that we are consuming in the form of various sources, that is in the form of eggs, milk, meat, oils, bakery products, they all contain nutrients like proteins, fats and carbohydrates, and these are all they are organic compounds. Then the natural fibers like wool, cotton, silk and nylon are also included in organic compounds which are used in our day to day life. That is, we are using wool for sweater, for keeping ourselves warm, and then silk is also expensive, and it is used as in generally making ethnic dresses. Then linen and nylon, jute, they are all organic compounds. That is, they include the organic compounds. Then fuels like petrol, diesel, kerosene, LPG, CNG, they are also examples of organic compounds. Then the detergents and soaps that we are using for cleaning things and washing clothes and cleaning ourselves also, they are also organic compounds. The commonly used expensive or cheap plastics in the form of the various products also include the organic compounds. You can see the plastics in the form of rubber that we are using in the form of rubber pipes, or whatever clothes that we are wearing, some synthetic, and the plastic containers that we are using or molds we are using, they all contain organic compounds. Even the paper, perfumes and disinfectants, they also contain organic compounds. So you can see that almost in all fields of our life, everywhere in our life, whether we are having a food or we are using fuels or using plastics, or even things that we are using for cleaning and washing purposes, and then the paper that we are using for writing, everything contains these organic compounds. That is, they find or they have a very big role to play in our lives. Is it clear? So our life appears to be absolutely impossible without the use of these. Carbon fibers are stronger than those of steel and lighter in weight, so they're using in making tennis rackets. This is also one use of carbon. Then we study other compounds also, that is, other than these organic compounds, that is the carbon and hydrogen compounds along with the derivatives. We also study other compounds apart from these organic compounds, and this branch of chemistry that deals with the study of inorganic compounds, that is, compounds apart other than these organic compounds, is called inorganic chemistry. So what do they include? They include compounds like carbon monoxide, you know the formula, that is carbon monoxide, and zinc oxide, aluminium oxide, then nitrates like nitric acid, calcium carbonate, HCl, they are all inorganic compounds. Is that clear? So inorganic chemistry deals with the study of all elements and the compounds except those of compounds of carbon and hydrogen. So over here you can see this simplest hydrocarbon. So this, the formula is CH4. This is the formula, so no need not go into the details. That is the structural formula which you will do in detail in higher classes. Then butane, that is butane, the formula is C4H10. This is the formula of butane. Then similarly ethene, the formula is C2H4, then ethine C2H2, then benzene C6H6, and naphthalene, that is C10H8. So you have these compounds which are all hydrocarbons containing carbon and hydrogen both in different proportions. They have different formulas. Then there are certain alcohols like methyl alcohol CH3, the methyl alcohol, that is the formula being CH3OH. This OH group, I have earlier told you, this is for alcohols. Then ethyl alcohol is C2H5. Is that clear? The formula is C2H5. So you have to learn these formulas, these formulae, learn all these formulae. Then acetic acid, what is the formula? CH3COH, that is the vinegar that we use in our food, is acetic acid. So the formula is CH3OH. Is that clear? Then formic acid, HCOH, oxalic acid, COH whole twice, and glucose, that is C6H12O6, and sucrose C12H22O11. Similarly, we have inorganic compounds like carbon dioxide, that is CO2, carbon monoxide CO, copper carbonate UCO3, and so on. Then there is an activity on page number 127 to show the presence of carbon in sugar. So here we have taken a china dish or a porcelain dish and a burner and sugar. This is all what is needed, and a wire gauge. So we take a small amount of sugar in this dish and heat it for some time. What do we see? We see that this sugar melts first. You can try this at home in a non-stick pan also. You see that keep the sugar only without water, it melts on heating, and on further heating it turns brown. Finally it turns black and gets charred. Is that clear? This process is known as charring. So what is taking place is that the formula of sugar is C12H22O11. Is that clear? So it gets charred. Now this, for making sugar, even sulfuric acid is mixed. So you can just leave this aside. Is that clear? So this sugar gives out, or water is released, and the carbon on heating, whatever carbon content, it gets heated and changes to black. So sugar gets charred. So we can say that sugar consists of carbon, and carbon burns in oxygen to form carbon dioxide and black residue. Is it clear? So carbon is present in sugar. This charring shows that carbon is present in sugar. So this is all for today. Allah Hafiz.